This is a Syndup Z20 from 1976. And when I was 15 years old, this was pretty much the coolest thing you could have. Now, I never got to have one. My parents thought it was dangerous, but my best friend had one. And we spent the better part of 1983 in a garage working on this bike, or moped, but we call it a bike. In the garage we were working, in the back of that garage we had a tape recorder. It was like a huge tape recorder with only one tape though, and it was all Thin Lizzy songs. And we played that tape over and over for the entire summer, while of course we were working on this bike, trying to make it go faster. And we did all kinds of stuff to this. We changed filters, we changed the exhaust, there was some drilling involved, I recall, and at one point we even changed the entire engine. But regardless of what we did to that poor bike, it always, without any exception, ended up going slower than before. And it got to one point where actually it's like the end of the summer, a couple of weeks before the school started. As we were in the garage, my friend was trying to kickstart the bike, and as he did, the engine exploded. It vaporized, and bits and pieces were flying all over the place. And he got really scared, jumped off the bike fell down, gasoline starts pouring out, and within a second the entire moped is on fire. I think we tried to put it out, but after some time that fire had extended to other parts of the garage. So we just bailed out. And I can still today recall as we were standing outside that garage, like two really scared 15-year-old boys looking at that mess we created. It was his father's garage, by the way. And the bizarre thing was that music, that Thin Lizzy songs, was still playing in the background. And this was like a good 15, 20 minutes later, when the fire department finally came up, the music was still playing. But now when the fire has reached the end of the garage, it kind of sounds funny. It's like the boys are back in town. So, of course, after that incident, none of us were allowed to use any mopeds. So we pursued other interests. For me, that was obviously computing, and it's kind of ironic that I stand here today talking to you guys about doing pretty much the same thing with BizTalk, right? But there's a lesson to be learned, and that is that performance is hard, it's difficult, and if you turn the wrong knobs, it's going to end up being worse than to begin with. So again, welcome everyone. I'm Michael Hakinson. I'm a BizTalk MVP. I work in Sweden for a company called Info Systems. I run together with a colleague of mine a user group in Sweden. I'm also quite active in the community through various open source projects in the logical namespace, such as the SFTP adapter and the benchmark wizard. So what's in it for me? It kind of depends who you are, right? So by show of hands, how many of you are developers? IT pros? Neither? Oh, crap. So you probably know that BizTalk is an enterprise product. It's robust, it's high performance, but it has dependencies to other things in the platform, such as SQL, storage, and more. So it's kind of like a chain is not stronger than its weakest link. So this talk is really about you finding those bottlenecks and resolving them. Now, for the last 2 or 3 years, I've been working a lot with the installation of BizTalk, and I find myself being sort of like a stakeholder, talking to various roles in the organization, such as people working on storage or hardware or operating system, about how they should set up this environment, so that afterwards that I can come in and set up and configure BizTalk. So if you can put yourself in that situation where someone perhaps has come up to you before and said, well, we need to process 100 orders per second. And you may think that BizTalk is a good fit for that, and of course it is. The next question is going to be, how many servers do you need? What's the cost going to be? And of course you can answer that question, but you go with, well, maybe for reliability reasons, let's start off with a couple of application servers, a couple of BizTalk servers, and a SQL cluster, and you go from there. So you do your first test, and you end up getting, what, 50 orders through, let's say 50 orders. So what is your next step going to be? Well, one way would be, well, let's buy another 2 application servers, or let's do active clustering, or buy some new memory or other hardware. And of course, all those changes might be necessary and might actually solve your problem. But before you do that, before you take on that investment, you probably should go back to see that BizTalk is really all it can be, that it's correctly configured. And that's where this talk is coming in. So the overview of this session is I have some more introduction. I'm going to then do a first test on my machine. That's going to be our baseline. And then I'm going to spend the better part of the talk about how you do, what kind of configuration you should do. What is the most important settings you should apply. And then I'm going to apply those settings. I'm going to run the test again, and hopefully we'll get a much better result. At the end, if I have time, I have some additional demos that I will go through as well. But this is pretty much the overview of the session. So the goal for this session, I should say my goal for this session is really that you guys should be more comfortable with these settings and understand them and feeling comfortable implementing them in your organization. So when we set up BizTalk, we always use the BizTalk optimization guide. This has been, the last one, the 2010 version, was released now in February. How many of you are familiar with this document? Cool. So I think that you all agree with me, those of you who have seen it, that this is a very good document. I'm equally sure that you will agree when I say it's a quite extensive document. I think it's like I see some heads nodding, it's like 360 pages or something like that, which probably tells you more about BizTalk than it does about the actual white paper. But it is a complex product if you want to nail down all the places where you might need configuration. So this talk is really about what are the top 5 or 6 things that you should apply out of all those things that are mentioned in the optimization guide. So when we're done with that, we use the best practice analyzer. If you're not familiar with this is a tool that you download, you install, you point it to the management database, and it will give you sort of reports of warnings and information and errors that you might want to look into. So after that, you're pretty much done. Or at least you hope you're done. It's a bit like doing a test where you will like study for the test and then you will do the test, but you'll never see any result. So I was working at customer site and we were punching messages through BizTalk and we got like 150 messages per second. And I didn't really know if that was good or bad. I had a feeling I can get much more. So I contacted this guy named Ewan Fairweather, who was formerly in the BizTalk cat team for Microsoft. He's now moved on to SQL cat team. And asked him if he had a scenario that he'd been running on his servers and had some numbers, performance counters for, and that I could run on my environment to see what values I would get. Of course, he didn't have one, but that sort of began a work that we did together to create what is called now the benchmark wizard. Now, this talk is not going to be about the benchmark wizard, but I will use it. So I have a few slides to explain what it does. So when you install it, you get 3 things. You get a wizard-like application that also works as a load tool. You get a BizTalk application that you install to BizTalk. And there's 2 scenarios in that application, one orchestration scenario and one messaging scenario. And then there's the backend service that is just a console application that receives all those messages from that send port. While that test is running, various counters are collected, such as the received messages per second and the processed messages per second from the send host, along with the CPU counters from all those boxes. And all those values are presented as gauges in the tool as you do your test. So when we were done with this tool, Ewan took it back to Redmond, to the test lab, and had it running on various environments. Anything from a single server to multi-core servers, multi-service with multi-core. And those values that we got were then incorporated into the tool as KPIs. So this second thing you get to do after select the scenario, you get to select an environment that as close as possible resembles the one you are on. So if you're running a single server, you could expect anything around 200 messages per second, whereas if you were running on two application servers with 8 CPU and a SQL box with 16 CPUs, you can expect anything around 1,000 messages per second. If you meet those values, you would, or exceed them, you will of course get a successful result. If you get 80% or lower or higher, you will get acceptable result. Whereas if you are below 80%, you will get a failed result. And at that point, you really should go back on your environment to have it rechecked, see if you can find bottlenecks. Now that said, the tool will not give you any hints or advice of what your problems might be. But if you enable it to, it can collect like hundreds and hundreds of counters and create reports for those counters. And you can later use the PAL tool, which I have a link to at the end, to analyze those logs to find those bottlenecks. So this is like 3 months ago, I was working at a customer site, and they had an environment with 2 application servers and a SQL cluster. The application servers were like 12 CPUs and 24 gigabytes of RAM, running on Windows Server 2008 R2 and the BizTalk Server 2010. On the SQL side, we had 16 CPUs and 96 gigabytes of memory. That showed to be way too much that we needed, actually. But we also run it on Windows Server 2008 R2 and SQL Server R2. That was the standard edition. So the values that we got, I don't know how well you can see it, was 760 messages per second. That was after the first installation, after no configuration was made. So after the configuration was made, actually apply the same things that I'm going to talk about today. We ended up with 1,300 messages per second. So that's a 70% improvement. And in terms of if you would have gone to invest in hardware and additional licensing, that's quite a lot of money. Now, we still only got an acceptable result, which was kind of irritating. But the reason for that is that we exceed the CPU counter there. For the value was 60%, and we got 63%, which kind of is okay, right? We get 70% more load, so that was okay. So let's run our first test. So I'll just show you first the BizTalk application. So when you install it, you get this BizTalk Benchmark Wizard application with a set of receive locations, 1 for each of those scenarios. You also get 2 send ports, again, 1 for each of those scenarios, and you get an orchestration for the orchestration scenario. You'll get 3 hosts. That is a receive host, a send host, a processing host. And as I will be running the messaging scenario, I'm not going to care about the processing host. So the first thing we get to do is to point to the management database. And this first step here is where it actually checks if you have installed BizTalk, the BizTalk application. And also, in this case, you can enable it to fetch all those counters that we're talking about that you can later analyze using the PAL tool. Then I get to select the scenario, the messaging scenario, orchestration scenario. And of course, I'm running on my laptop, so that would be a single server, kind of. In this case, I need to tell the tool where to pick up those counters for the CPUs and receive messages and send messages per second. Then I have to start that backend service. See what it's. So the first step we got to do is to test that we actually have a connection here, so we can verify that. We set the time for how long we will test this. I would recommend running anywhere above 15 minutes, really, to get a consistent test result. But I guess you don't want to wait for that. So I'm just going to start the test to see that everything is running. And after that, I will continue with my presentation and come back to the result later on. So there we go. So BizTalk performance. What is BizTalk performance? Well, as you know, BizTalk relies heavily on SQL. So that means that BizTalk performance is pretty much SQL performance. In fact, the improvement that we've seen over the years for BizTalk really relies back to the improvements that has been made on SQL. Furthermore, SQL relies heavily on storage, which is also a very important factor in the equation. You may think, well, I'm a developer, what do I care? Well, when someone comes with requirements to you about how you want them to build, how they want you to build a solution, You probably expect them to understand what a schema is, or what transformation is, an orchestration, maybe a rule. It's kind of the same thing here, that if you are a stakeholder setting up those requirements for people to set up your environment, it's probably easier if you speak their language and understand what you can ask for. These roles in the organization might not strive for the same things that you are. So where you'd be focusing on performance, like the storage guy, he's the guy who's in charge of an insanely expensive storage system. He might strive for cost efficiency. This is not necessarily a bad thing, but this might be good for you to know. So, when you create a database, or you would have one created for you, as when you install BizTalk, you will get 2 files per database. And like in the case of BizTalk, that is like, what, 7 databases or something. And I think it's kind of common knowledge to put those files onto different volumes. Sometimes I come to customers and say, well, we use this sound system where we have multiple disks behind it, so we don't really have to separate them onto different volumes. Well, the fact is, on an operating system, there's a disk queue, and you will have one of those disk queues for each of the volumes. So it is very important to have multiple volumes and stick them into different volumes. Otherwise, that will become a bottleneck for you. So if you concentrate on that data file, that is made up of a series of data pages. They're all the same size, they're all 8K big, but they're different types. Most of them are data pages, obviously storing data, whereas there are also some special pages, such as the PFS page. The PFS stands for page free space, and this little page keeps track of all the free space in all those data pages. So if you make any like insert, update, delete, whatever change you make, that information needs to go back to the PFS page. Now, if you're working on a multi-core environment, which I expect most of you are today, that's going to be a problem, because the first thread that comes in, or the first scheduler, if you will, is going to require a lock on that PFS page, setting all those other schedulers to have to wait until that lock is released and it can continue. Now, the good news is there's a simple way to resolve this, and it's by splitting up that data page or adding additional data page files. And the recommendation is to add 1 per CPU. It doesn't mean that the file is dedicated to a certain CPU. They're actually addressed in a round-robin fashion. But it will alleviate a lot of that contention for you. And this is really true up to 8 CPUs. If you have more than 8 CPUs, you don't have to add anything more. So if you create multiple data files, they will still be on the same file group. And so one file group will be stuck in one volume. But there is a script in the optimization guide which you can use, and it will separate those indexes and less used tables from those holding the parts and spool tables that you will find frequently used. And they will create file groups for these, and you can put those files now onto different volumes. And the more you separate here, the better throughput you're going to get. And you can, at least you can resolve all these, what we call a single page allocation, by a flag that is called T1118. This is a flag that you set on the startup parameter for the SQL service. When I'm going to apply this at my demo, I'm going to do this using a dbcc command. And the advantage with that is that you don't have to restart the service. However, when you do restart the service, that setting is going away. So for your environments, this is really how you want to apply it. So the test is actually done. So we got 170 messages per second, expected 200. I think this is still kind of good, but we can do better. So what I do here is I'll just close this down, and I will reset my database. So we keep that number in mind, 177. sometimes it's better to keep things together. This is true. So again, the data file, large number of data pages. And if you look at one of those data pages, you will find that it has a number of records. Each record represents a row in a table. Now, if you have LOB data types there, that would be image and text, for example, and you find those tables where you store the actual message or the content of the message, such as the spool table and the parts table. For those columns that have these LOB data types, those values will not be stored on the same page. And it kind of makes sense because the page is only 8K big, and an image column could be any size almost. But there's this text in row table option that you might consider applying. And this is where you set a size that could be no more than 7,000, that is 7K. That if the record is less than that size, then the entire record will be stored on the same record. And I've seen very good performance applying these, not only for latency and throughput, but also for utilization of CPU. So this I really recommend. And we do this again to the spool table, the parts table, and the dynamic state info tables that we'll find one for each host. Yes, sir. Is there a reason why you wouldn't enable this option? Why you wouldn't? Yeah. My only concern with this is I want to enable this, but I don't know what if my messages are too long, or my messages are too big, or does that have anything to do with this? So the question is, why would I not do this? So the question is also, well, if the message extend like 7,000, no, then it will fall back to the same behavior as you would have before. In fact, the image and the text data type, they are obsolete. They're going out and replaced by varchar max and var binary max. And those data types actually have that behavior already. Yes. So, I/O. So we resolved one bottleneck. That was the PFS contention. So do you know what happens when you resolve a bottleneck? You get another one, right? So we resolve the PFS contention. That's going to move us to I/O contention. And we talked about this before, that we will put those data files onto separate volumes. And this is a good thing. Well, a little bit about I/O. I know you all know what this is, but there's 2 points I want to make. So this is a hard drive. It's made up of a series of platters. They're all mounted to a cylinder in the middle, and they all revolve around that cylinder as it spins. The cylinder is called a spindle. And from a developer's perspective, you might hear people talk about spindles and spindle counts. What they're all talking about is a hard drive. The second thing I want to make sure is what's on the bottom here, where it says 250 IOPS. That is read and write operations per second. Now, if you can afford it, I will recommend you to use solid-state drives. They're not that new anymore, but they're getting so cheap that you can really afford them in most scenarios. If you can, please take these, apply these kind of disks to your system, at least for the log files, because splitting up the data files we were talking about before is something you can only do on the data file. You cannot do it on the log file, unfortunately. So, but if you still can't afford this one, there's another kind of cheap SSD drive. It's called short stroking. So if you have a disk drive and you partition it to 2 volumes, the first volume is going to be on the outer rim, and the second one on the inner rim of those platters. And as you know, the outer rim spins much faster than the inner rim. It's going to make that particular partition twice as fast. It's a cheap way to do it, at least for the log file, as I said before. When I come out to the customer side and there's been trouble, the first counter that I would look for is the checkpoint. So this is the performance monitor, perfmon, and the checkpoint counter is in the SQL buffer manager space. So, contrary to what many believe, SQL is always working in the cache, in the buffer. So any changes made to those data pages that we've been talking about before is made in the cache. At one point in time, SQL will need to persist that data, those so-called dirty pages now, down to disk. And it does so with a mechanism called checkpoint. So in a normal situation between those checkpoints, you can assume anything around 4 millisecond latency on your read and writes. While during that checkpoint, you will have that times 10. And that's okay, but it's really important that you keep those checkpoints as small as possible, as fast as possible. If you come to a customer site and it looks anything like this, then you have a problem. And most certainly, you have an I/O problem where the I/O cannot absorb all that data. So then you have to look at what your disk counters looks like. I'm going to mention a little bit about SON storage. This is very complicated, but again, it's just to make you better to set up those requirements. A SON system is made up of a series of disk arrays, and a disk array is made up of a series of disks. And from a disk array, you can create any number of LUNs. LUN stands for logical unit number, and it will end up being what you see as a volume on your server. The key point here is any number of LUNs, because it's very likely that you will end up sharing that disk array with someone else. And if you share it with another BizTalk, I wish you good luck. You will never, ever get any performance. Now, as I said earlier, there's been improvements lately for the SON systems. They are really catching up. For the last 2 years, they've been much, much better. And they may not end up talking about disk groups. So if you're lucky enough to work with a SON system where you have disk groups, this is not so much of an issue. But then you have another point where it's called a port. A port is where all the data is transferred through, and you need your own port. So if you're working in older systems, you need your own array, or otherwise your own port. Now, if you look at the optimization guide, it says use RAID 10. It doesn't explain so much why you should need RAID 10. So we can talk about RAID systems for about 2 sessions. So this is going to be like a crash course of RAID for about 1 minute. So RAID 0, which is not really a RAID, but it's called RAID, so it's relevant, I guess. It's called striping. It requires 2 disks, and it will read and write either one of those operations to either one of those disks. So it's very, very fast. It has no redundancy, though. So that's not really an option for BizTalk, right? The second one is RAID 1. It's called mirroring. It will write all the data to one disk, and it will mirror it to the other one. So it has very good redundancy, as if we will lose one disk, we can just recover it from the other. It's slower than RAID 0, but it's also more expensive, as you will only use half your storage capacity, really. Now, RAID 5, which is the most popular one, I suppose, is using another mechanism for redundancy. It uses all the disks except one for storing data. And the last one it uses something called a checkpoint. So when you write data to either one of those disks, it's going to calculate a value of that position together with the position of all the other disks and write that data to the last disk. So it's fault tolerant in the sense that if you lose one disk, you're still okay. If you lose 2 disks, you're in trouble. It has very good read performance, but that extra time it takes to create that checkpoint value and write it to the last disk, it makes it less good for writes. RAID 10, which is only RAID 0 and RAID 1, or 1.0, depending which order you do it, has the total redundancy from mirroring. It has the increased write transfer rate, but it's still kind of expensive. Again, you're only using half the storage capacity. So BizTalk, we write a lot of stuff to disks. So for the extended transfer rate on write, this is much preferred. However, again, the new sound systems have huge caches, so it might not be so much of concern. But keep a dialogue with the storage guys, so maybe they say that you can work with RAID 5 anyway, and you probably should listen to them, but just to know what they're talking about. So from the BizTalk perspective and from the optimization guide, we recommend RAID 10. Some useful counters that you might have a look at. The available memory megabytes. So this would be all the memory you have available, and you would not want that to be less than 25% of what you have on your box. In that case, you're going to see it start swapping things to disk, and this is what this other counter would indicate if it's less than 5. Average disk read queue length and write queue length. This should never extend anything around 2. And you can also have this read and write per milliseconds. It's also a counter that you can check for. And you should, I think I've been nice here, saying less than 10 milliseconds. I would require anything around 5 milliseconds, really. We talked about the checkpoint and how that is really important to keep those as short bursts as possible. As you probably know, there's a lot of throttling going on for BizTalk, but it's keeping its health. So watch out for those throttling. There's actually more than these. You should watch that state. It should always be 0. 0 indicates that there's no throttling going on. There are different reasons why BizTalk would throttle, and those are reflected in the numbers. Number 1, 2, 3, 4, and I think it's up to 6 will indicate why BizTalk is throttling. The spool size. The spool is all the messages that comes into BizTalk, and it's lying in the message box. If you see this just going away, it's not coming down or stabling out, that probably indicates that you have your the SQL agent is not running. If it is running, then you have to go further to investigate. But if it just goes away, it's almost always the message agent hasn't been started. Yes? There are some other counters that would be more relevant in that case, really. So I'll just put these up because they're the most relevant. There are many, many more counters to watch. And if you use the poll tool, all those values will be there. I just put them up here as a reference. I know you won't remember them, but maybe you can keep the slide deck as a reference.
This slide seems missing from the slide deck. Are you going to update that?
Come again?
This slide seems like it's missing from the slide deck you have posted.
Yes, true, because I made these changes today. They have not been posted out yet. So good point. I forgot to mention that before. They said there was a 2-hour delay before they're actually available on the site. So I will check after that again. I will check after this talk, and if it's not there, I will go down and tell them to. So if you downloaded the slide deck, please do it again. So at this point, we come to where we're going to apply those settings to our environment. And again, we're going to separate the data and log files to different drives. As I said before, I only have one drive, so I can't really do that. Then we're going to partition the data files from the message box, the DTA, and the tempDB, so we have one per CPU. We're going to separate the indexes from less used tables, from those like parts tables and spool tables, onto different file groups. Again, I won't see much of an improvement from that, but it shows you how you do it. We're going to apply the text in row table option. Those were the ones where we kept the data together on the single page. And we're going to allocate enough storage. I actually made that already. And we're going to enable the T1118 flag. Right? Yep. So how much performance increase do we see from adding additional message boxes? So there's a couple of things there you should know that you should, when you add a message box, you should add 2, right? So everybody knows that. But I haven't seen that much improvement. I've done quite a lot of testing actually with that, and I haven't really seen much of an improvement. Come in. I can't hear you.
It adds overhead.
Yeah, it's overhead. Yeah. 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 So if you do, you should really be on an active cluster and have them on different volumes. But still, I've done that, and I haven't seen much of an improvement. And actually, I've been working those tests together with the BizTalk cat team, and they haven't really seen much of an improvement. So just see, I have restored my database. Yes. So the way you can look at the data files through properties on a database, you go files, and you can see I have one data file and one log file. So we will start up by adding additional data files to our DTA database. And by the way, all those scripts that I'll be running today, I will put them up on my blog, and you can download them later on. You could, of course, do this step manually also, if you will. The only important thing is keep them in the same size and the same growth on each of those files. No, I have 4 CPUs. So again, you don't need to do it more than 8, but I have 4 CPUs, I add an additional 3. I did the same thing for the TempDB. And for the message box, that script that was talked about before, that separated into different file groups, that script actually does that for me. So I'll add that one as well. This is quite long, but there's just a section that you need to change. This section. So here you will say how many files per group, and I use 4 because, again, I have 4 CPUs. I'll set the initial file size. I set that to 100 megabytes because that's what I have on the other one. I set the growth, and I also set the path to where those files are going to end up. And of course, at this place, this is where you would separate them out on different drives. That makes sense? So we'll run that. So those are the only values you need to set. So now if we look at, for example, the message box. Sorry. Yeah, but I know this won't matter. So I'll just ignore them. So if we look at the... this is not right. Did I take the management database? Yes, I did. So now it looks like this, right? Looks like a lot of files. And it is, I guess. Then we'll apply the text and row table option. Again, these are on 4,000. That would be equivalent to that would be enough for my demo, though. And you can see how you apply them. This would be the table, and I'm running 3 hosts. If you recall, I'm actually just running 2 hosts, but you do this on each of the hosts that you have. And the last one is the maximum value for that record. And that could be maximum of 7,000. What? So the last one, the dynamic state info table, these ones. You would have one of those for each of the hosts that you have on BizTalk. So each host will create that table. And lastly, the T1118 flag. So again, when you apply this, you would use it not like I did. I'll show you. SQL Server, configuration. Where are you? There you are. Here's the startup parameter, and you would just add it like semicolon dash T1118 flag. Don't forget the semicolon though. I've had some incidents when if you forget that and you work in a cluster environment, the whole thing goes berserk. It just flips back and forth from the cluster all the time, and I didn't end up fixing the problem. I had to reinstall it. So don't forget the semicolon. Someone's going to call me after this talk and say, well, what have you done? There is. So we applied all those settings. Starting up the tool again. Selecting the single server installation. I have the Indigo service started already. So we run that again for 4 minutes. So that's to get you in the mood. Hey! That's all you're going to get. You can hear the other room over there so much. They're probably wondering what we're doing right now. So what we talked about so far is everything you can apply to an already existing working environment, right? So while this test is going on, I thought I would share some of the like incidents and stuff that I often run into. So first of all, you don't run performance tests as I do on a laptop or a desktop, right? You can do it, of course, but don't let it reflect the performance of BizTalk. Beware of virtual machines. I don't mind it so much for the BizTalk servers as for the SQL. So I would prefer always to use it on SQL. Besides, if you work in a clustered environment, sometimes there's no possible way to actually cluster them. My experience is not good anyway with that. So if you're testing BizTalk using files and you have a file share out there, be aware that there is a connection limit on a file share. That there's a register setting that you might need to tweak. Otherwise, that will become your bottleneck, not really BizTalk. Message tracking. So that might be something, if you work in a high throughput system, that might be something that you consider switching off. Again, it's on a group level, so that will affect everything in BizTalk, but you will still see the suspended messages, right? The only negative thing besides not having a history is you can't debug orchestrations. But you might consider switching it off. It has about 15% overhead. Remember virus protection software. I was working in a customer environment, and we specifically said that we wanted exemptions for our database files where they were stored. And they said, well, we're not going to install any virus protection software at all. So fine. Again, we're getting these 150 messages per second through, and I involved better part of Microsoft and the BizTalk cat team into solving this problem. And like three weeks later, someone came into the office and said, well, we did set up the virus protection software. Of course, we were checking for it, but our company policy was to have F-Secure. And they used, of course, another virus protection software where we couldn't find it. Default autogrowth on the settings you set on each of those files, keep that quite big, and don't use a percentage. Use like 100 megabytes and make it big to start up with. Make sure the SQL agent is running. Again, if the spool table just going up, it's most likely that the SQL agent job is not doing its job. So, contrary to what some people believe, when a message leaves BizTalk, you would assume it's removed from the message box, right? But it's not. It's just flagged that it's to be removed. It's actually the SQL job. The SQL agent job goes afterwards and cleans these jobs up. So even though the message is gone, it will still be in message box. Restore the databases for every test. Set up a script. you didn't see much of my script. I have a PowerShell commandlet that I've developed, and it's on my blog. You can use these kind of scripts to easily just restore the databases after each test. Otherwise, you won't be testing the same thing. And also, if you have problems, it's most likely that BizTalk is actually throttling. So have a look at those counters. Oh, actually, I timed that very well. So we ended up 260 messages per second. What was it had before? 177, right? So you can see that it's a lot improvement. I actually thought I would get some applause there, but never mind. Thank you. Forward. So with BizTalk Server 2010, they provided us with this wonderful UI called the Performance Dashboard. And in previous versions of BizTalk, we had all those settings in the registry, in configuration files, and sometimes in the database. And they were kind of hard to manage. Sometimes some of those settings were on each of those servers, so they could be different on different servers. Now, this is all aggregated up into the same UI, which is really good. And one of the best things is that some of those settings are actually pulled down from like a group level to a host level. And this is true with the polling interval. This is actually my favorite feature. So you can change this before, but it was a registry setting that would apply to all hosts for the entire BizTalk. So that ended up, for many of the customers that I've been working with, they ended up with having two BizTalk servers, BizTalk groups, I should say. One for low latency and one for batch and default scenarios. So now when you can set that on a host level, you can sort of like have all those scenarios onto the same group. So I have a very complicated orchestration. So it's just to show the response time. So I actually just receive a message, send it back. I will open up a performance. The counter I'm going to be looking for is this. It's called request response times. And I have a load gen script that I will just execute first as a warm-up. So now we'll actually enable it and let it be running for 1 minute. Maybe I should start it as well. This is not what I'm looking for. Oops. I'm going to restart the host and hope for the best. That always solves the problem, doesn't it? Oh, I think I know what it is. No. No. What? Yeah, I thought. Oh, actually, it's. Oh. I don't know why it's not started, but we'll see. I have a bad feeling about this. Well, let's try it again. Yeah. As a speaker, that is a good thing. Demos finally work. So I'll just run the real demo here again. We're running for 1 minute. So again, the entire graph here is 1 second. So you will see it end up anywhere around like a half a second. And the reason for this is that the message comes in, we put it in the message box, and the host will pick it up with an interval of 500 milliseconds. And then it's going to process it, send it back to the message box, and again, the receive host is now polling for that message with a 500 millisecond polling interval. So the average here will be around 500 milliseconds. So you can see this is where that's actually the average. So a little less than half a second, right? So we'll stop that, let it go. And while that is going on, I'm going to go to my settings on the dashboard and go change some of these settings. So down here are the settings for the polling interval, both for messaging, that would be when the receive host is picking up the messages, and the orchestration. So we'll set that to 100 milliseconds. And restart the host. What?
Change a different host. Change in
Oh, thank you. So they haven't fixed that bug yet. No, just kidding. So we'll do a warm-up so that we get some messages through. Great. Do the same demo again. And as we expected, we get a much better throughput, a latency of around 10 milliseconds, or 100 milliseconds, sorry. What? Like the 500 milliseconds, why it's the default? You're the Microsoft guy. Yeah. Oh, okay, fair enough. I wouldn't know, but if you have, I actually could answer that. If you have all your hosts, it's like for a current environment, I think we have 20 hosts, something like that. Like now we probably have 12 hosts, and we have multiple instances, so we have a lot of instances. And if each of those were polling with a really high frequency, that would actually be a problem on the message box. Yeah, we would have low latency hosts where we have these kind of settings, and they might have batch hosts, which they could poll one every minute if we wouldn't care. Come again? Yeah. Yeah. There's a lot of settings in there. I'm going to go through a couple of them right now, actually. Where's that thing? Yeah. Well, host instances, really. Yeah. We tend to, when it comes to 64-bit, you can add a lot more hosts than you could on a 32-bit system. I wouldn't know. I know that... Yeah. I wouldn't worry so much about the amount, but again, the polling interval. If you have hosts that are just doing batch jobs, why have it polling every twice every second? So each host instance is actually a Windows service. So yeah, it's a completely different service. So this is ending up being a discussion. We can take that afterwards. I'm just a long time. So F is for forward. Yes. So some of those settings are unfortunately still for 32-bit systems, even though you might install them on a 64-bit system. One of those are the virtual memory throttling criteria, which is a criteria where if you exceed it, BizTalk will start throttling. And again, this is set for 32-bit systems, and you need to change them, as I suppose most of you are running on 64-bit systems. And in the optimization guide, there is a section where you can calculate that value. Persistence points. So this is where you have an orchestration, and it comes to a certain place, and it needs to persist so it can recover from that point later on if there has been a failure. Try to scope these shapes, because almost every shape will cause a persistence points. So by putting them in a transactional scope, that will only require one persistence point. And sometimes we put all our variables, like in the orchestration, like variables and messages and such. If you put them in the scope, there will be much less information that will be persisted each time the BizTalk will persist. Otherwise, it will need to take all those messages that you created like weeks ago. If this is a long-running transaction, all those will be persisted as well. Context properties. I find that sometimes when I develop and I come with an expression shape, it's kind of nice to do, well, message.customer. Right? It's easy to use. It's easy to maintain. But all those distinguished fields that you might use will end up making the context of the message much bigger than the actual content. So because that will store the entire namespace with its root node and value and everything. So from a performance perspective, it's better to use the XPath. Pipeline components. If there's any place where I tend to see people making mistakes, it's in pipeline components. You should keep in mind that BizTalk really works in a streaming fashion. Yossi Dahan was previously a MVP. He bailed out and joined Microsoft, but he did write a very good white paper on how you can use streaming while you're developing your pipeline components. There is an assembly called Microsoft BizTalk Stream DLL, and this is, you will find this in the installation directory for 2010. If you're on previous versions, you actually need to copy that out from the global assembly cache. It's kind of a tweak. I can show you later on if you want to know how you find it. But that assembly has some really interesting streams that you can use. Like the virtual stream is a stream that if the size of the stream exceeds, I think, 1 megabyte, it will store that data as it will actually become a file stream instead and make use of the file system, relieving those resources. If you need to copy something or from the message, you can use the XPath mutator stream. And sometimes when a message comes in without a namespace, there are a couple of streams you can use to extract that information or put in a new namespace if you want. Pass-through pipelines. Use pass-through pipelines when you can. Sometimes you come in and see a send port, and they use an XML transmit pipeline. There's no real reason for that unless you are validating that data. So on a send port or a response message from a receive location, try use pass-through pipelines as much as possible. You should only promote properties when you need them to route or you need to demote those properties to a message. Sometimes we tend to promote them just so we can find the message in tracking. Try not to. There's a couple of helper utilities you can use to actually instrument your solutions so that someone else can look, for like example, using the debug viewer and such to see what actually happens in your system. Transactions and in-order delivery, those are really things that might have a large impact on your messages as well. So with that, I thank you very much for attending. When you come back home, you will not remember. I know that there's a lot of stuff I spoke to you about today. Use this slide deck, again, when it's updated, as a reference. And give me a ping, throw me an email, and I'll be happy to help you out in whatever problems you have. I have a blog where you also find some other relation to performance. SQL Cat blog is, or the AppFabric Cat blog is also a very good source. You'll find the benchmark wizard that I showed you. That will be available on MSDN. The best practice analyzer was the tool that I mentioned in the beginning, along with the PAL tool which you can use to analyze those logs. There have been some sessions that I think is relevant to this talk. They're already been they're finished already, but you can back through the online versions. And if you don't have any questions after this talk, I'll be down in the booth and I can take questions from there. Thank you very much.